figure shows an arrangement to measure the EMF and internal resistance of a battery. The voltmeter has a very high resistance and ammeter also has some resistance. The voltmeter reads 1.52 volts when the switch S is open. Now when switch S is open, there will be no current flowing through the ammeter, and due to the high voltage of voltmeter, the net current that will be flowing through the battery will be 0. So if I use Kirchhoff law, then it comes like EMF minus 1.52, that is the potential drop across the voltmeter, minus I into R equal to 0. This R should be small r, that is the internal resistance of the battery, that will be equal to 0. Now since the current flowing is 0 due to the high resistance of voltmeter, we have EMF as 1.52 volts. That is the answer for the first part. In the second part, we had to calculate the internal resistance of a battery. So for that, let us read second part, that voltmeter reading drops to 1.45 volt and the ammeter reads 1 ampere, and we have to calculate the internal resistance. Now since the ammeter is reading 1 ampere, we'll use again the Kirchhoff law, that is E minus IR minus 1.45 equal to 0, because now the potential drop across the voltmeter is 1.45. Obviously the current that is flowing is 1 ampere through the ammeter. So if 1 ampere current is flowing through ammeter, obviously no current will be going in this direction, so whole current will be going in this direction, that is 1 ampere. So it goes like this. EMF is 1.45 plus of IR. We have EMF as 1.52, 1.45 plus current is 1, and this R is again internal resistance, so I'll write it as small r. So small r comes out to 0.07 ohm. That is the answer.